It's a whole planet out there with a complicated history. That history is a story that's stored in the rocks, and our job is to figure out that story and what that story of that planet tells us about this planet that we live on.
The recommendations of the Science Definition Team to NASA are to fly a rover of similar capabilities to the Curiosity rover that's still on Mars, that would land in the same way and have about the same size. And we are recommending that they equip that rover with instrumentation that allows it to explore the surface of Mars in one site, which will have relevance or importance to understanding past habitability. Did it have the conditions necessary to sustain life? And to look for signatures or rocks that may hold signatures of biological significance.
So where Curiosity takes rocks and grinds them up into powder and looks at their bulk constituents, what this mission would need to do is be able to look in a microscopic level and examine the rocks for these very tiny and detailed messages that they would be sending to us about the past life that could have lived there.
So the sorts of evidence we're looking for, sorts of signatures of past life that we would be looking for would be signatures of microbial life. So not realistically looking for dinosaur bones and that kind of thing. If life ever existed on Mars, we expect it to have been microorganisms.
This that I'm holding up here is a classic biosignature from the Earth. It's a fossil. We're not actually expecting to see a fossil of shells or other components, but what we want to be able to see are, with this instrumentation, are the fine scale layering that one might see in a rock, in which we can see dark and light toned layers. And those dark and light toned layers are telling a story.
We wanted to do something that would make technical progress, and that thing was going and coring rock samples, putting them in a little container, a cache, and storing them for bringing back later.
Because no matter how well instrumented a rover is, we can't look with the kind of detailed understanding that we would have in laboratories back here on Earth.
We can do so much more in the laboratory on the Earth with equipment that exists now, and who knows what's going to get invented in the decades ahead that can still analyze those rocks.
The human flight component would like to see an experiment where resources on the surface of Mars, from the rocks or the atmosphere, could be used to generate fuel or other parts that would enable future exploration in cutting the tie, so to speak, to Earth. So you wouldn't necessarily have to bring everything with you. You can actually manufacture it on the planet. And that's a really exciting additional component that we've been exploring and analyzing in this work.